Okay, let me break it down for you.
Judgment, prejudice, bias, it all still exists.
If I want to take this huge, overwhelming problem, I have to start with myself.
Finally clicked for me.
Compassion is a necessity.
Hello everyone, my name is Jun. At the first, for my beginning in my presentation, if you don't understand what do I say, please raise your hand. So, have you ever wondered if winning the lottery pulls chance or is there a way to predict it before it happens? Some may say it's just a luck, or is math behind it. The solution may be permutation and combination. I know not everyone is interested in math, but I will try my best to keep you guys awake. So what I'm going to talk about what I'm going to talk about today is what is permutation, what is combination, and I will start with a demonstration using our seating arrangement, and then go on to Rubik's Cube, and last, blackjack. So, what is permutation? Permutation is a part of statistics that can show us the random arrangement of stuff. This could be relevant to our daily life, but you just don't perceive it yet. And what is combination? Combination is a way of selecting items from a collection such the order of selection does not matter. So, what is this? What type of lock is this? Combination lock? No, you are wrong. So this is not a combination lock. Let me explain. For an example, the password for this lock is 724 or 218 or something like that. It won't work for the random number. It must be exactly to be 218. So if the order doesn't matter, it's combination. If the order does matter, it's permutation. So we should really call this to permutation lock. You can understand permutation as is an order combination. Yeah. So permutation is the act of rearranging or permutating all the members of set into some sequence or order. Are you wondering what does that mean? Yes. Okay, let me break it down for you. Permutation could be our seating arrangement. The simple example is our seating arrangement right now. So who are you sitting next to? Will you be sitting next to this person another time again? Chances are. So let me pick 4 volunteers. Yeah, this 4 guy. Yeah, could you guys try to figure out how many ways can you guys be arranged in here?
24.
Yeah, it's 24. But how?
Okay, this is the first one.
2. 3. 4. Yeah, wait. Does that work? 5. No, you go there. 6. No, you go there. Yeah. 7. 8.
Yeah. Thank you very much. Yeah. As they do it first. Oh. It's like this, and they get the table in there, but actually we have a faster way to do it. We can rewrite it to 4 times 3 times 2 times 1. In statistics, we can also rewrite it, use 4 factorial, which mean the same thing as 4 times 3 times 2 times 1. So, who know what this is? Yeah, it's a Rubik's Cube. So, did you know Rubik's Cube is more than 40 years old? In 1974, a young professor in Budapest has increased the impossible object. If you turn Rubik's Cube every second, it would take you 100 trillion years to figure out, to go through all the possible configuration. Yeah. So this is the more further information if you want to read it. And however, today I'm not going to talk about how to solve it because it will take too long to do so. I'm just going to talk about permutation with the Rubik's Cube. So there are so many possible states of 3 times 3 Rubik's Cube. You could never finish just solving it, turning the face randomly. Even a 2 times 2 pocket cube has more than 3,500,000 possible permutations. This strategy wouldn't work for a 2 times 2 cube either. So the classic version 3 times 3 has much more pattern, and it has 43 quintillion permutations. So to illustrate this number, if we have as many 16-meter large Rubik's Cube as there are permutations, we could cover the Earth 275 times. So there is so many cubes in there. Yeah. So it is not easy to calculate the whole cube permutation, but we can start this easy thing first. We should break it to the 3 parts: first, corner, edge, and center. So the corner have 3 sides and 8 corners in one Rubik's Cube, which means the total size of all the corners are 24, which is the number of permutation of this case 24. And then we start to reposition the second corner, which is 21. But why is 21 is not 23? Because it has 3 sides in one corner. So we should minus 3, then we just continue until we have changed all 4 corners. So finally, we can guess the corner pieces is like 21 times 20, 24 times 21 times 18 times 15. Then we can go for the edge, but we just do the same thing with the edge, which is 24 times 22 times 20 times 18. Then we can go for the center, but we have changed a little bit the number for the edge because we have 12 edge in one Rubik's Cube and they have 2 sides. So we start with 24 and we should minus 2 of the number. So it's 24 times 22 times 20 times 18. Then we go for the center pieces. They have 6 faces, so it's just plus 6. And we can guess the number. So, but to configure out the possible configuration, I mean the whole cube, you have to say that your 8 corner pieces could be in any 8 position. That is 8 factorial, so it's here 8 factorial is like 8 times 7 times 6 until times 1. Then each of that could be in any 3 orientation, so you will have to take the 3 orientation and put it back to power of 8 and multiply those numbers together. And finally, we do the edge pieces, which is 12 factorial, and it's just the same thing with the corner pieces, and it's just the same thing. So then we finally to power of 12. Then, but why we don't have to calculate the center pieces in the whole cube? Because when we all know that when we rotate a cube, the only thing it doesn't change is the center pieces. So we got nothing to do to the center pieces. And now there is only one problem with this equation. If you don't take a cube, if you don't cheating, take a cube apart like Francis did, it's just you cannot do 2 things. The first thing, you cannot rotate a single corner or edge pieces. The second, you also cannot swap only 2 pieces. only 1 in 12 of the possible combination you could achieve by taking the cube apart and putting it back together are actually reachable by simple manipulating the cube, given that you simply need to divide your result by 12. So the answer would be like this, but I don't know how to read this number. So I just search it from the internet. It's like this. Oh, what are you searching? Yeah. So it's quintillion, quadrillion, trillion, billion, and million, and thousand. So we can go for the another fascinating thing, which is combination. And imagine you are having dinner in the restaurant. You have a fish, a beef, and a chicken. You can choose 2 of them. Say a fish. No. Say a fish and a. Say a beef and a fish, a beef and chicken, or a fish and chicken. So there are 3 combinations of 2 that can be drawn from this set. So here is the simple example for the combination. And now we can use it in the blackjack. So how do we use this? So this is the rules of blackjack. I'm going to introduce what is blackjack first. And blackjack is the most widely in casino. So how do you play it? Get 21 pawns as close as possible to goals without over 21, or a final score higher than the dealer is the basic rules of blackjack. But there is a biggest rule in casino is when you're under 18 years old, you cannot go into a casino. So never think about it, kid. And so how do we play it? Whether to hit, whether to stand? Fortunately, experts have discovered the game mathematically and figured out the proper way to play every possible hand. That table are called basic strategy. All come from the combination is like this. So, in other words, telling the blackjack player whether she or he should take for every possible combination. I mean, when you're playing blackjack, it can increase your chances to win the game, and it is not illegal to any country, so you just have to practice and practice again. You will be able to do it, so everyone can do it. And to be honest, it is not memorized all of the basic strategy. You can be able to do it. You also learn how to count cards. But it is not really relevant to the combination. You have to discover by yourself you're really interested in. And Richard Feynman is scientist, philosophy, and musician who said nobody ever figure out what it's all about, and it doesn't matter, explore the world. Nearly everything really interesting if you go into deeply enough. So math is amazing, life is amazing. Math helps us understand for more about the world where we live in. When you are smarter, you can appreciate, understand, and enjoy the beautiful complexities of life. So please allow me to finish my presentation with this video. Yeah.
I have a friend who's an artist, and he's sometimes taken a view which I don't agree with very well. You hold up a flower and say, look how beautiful it is. And he says, you see, as I as an artist can see how beautiful this is, but you as a scientist, take this all apart and it becomes a dull thing. And I think that he's kind of nutty. First of all, although I may not be quite as refined aesthetically as he is, that I can appreciate the beauty of the flower. the same time, I see much more about the flower than he sees. I mean, it's not just beauty at this dimension, there's also beauty at a smaller dimension. I could imagine the cells in there, also the processes, the complicated actions inside, which also have a beauty. The fact that the colors and the flower evolved in order to attract insects to pollinate it is interesting. It means that insects can see the color. It adds a question. Why is it aesthetic? All kinds of interesting questions which the science only adds to the excitement, the mystery, and the awe of a flower. It only adds. I don't understand how it subtracts.